Let us have a comparison of neuromuscular junctions of skeletal muscle and smooth muscle. We have already seen the neuromuscular junction of skeletal muscle. It is so discrete, isn't it? It's having a motor point where the motor nerve is making a contact with the skeletal muscles. A well-defined motor end plate. When we come to the smooth muscle, as you see there in the diagram, in the frame, there is no well-defined structural organization of neuromuscular junction in the smooth muscles. Instead, you can see multiple expansions. They are called varicosities running over the surface of the smooth muscle. There is no fixed point of contact. The neurotransmitters coming from the varicosities spread onto the smooth muscle surface and induce its effect. Such a synapse diffusely over the smooth muscle is called synapse en passante. Such an organization you are not getting in a skeletal muscle. Now you can see the structural details of a single smooth muscle fiber in the given frame. If you look at the smooth muscle, instead of a cylindrical shape that we got in skeletal muscle, here we are getting a spindle shaped smooth muscle cell. Of course, there are no cross striations at all. Well-defined nucleus is there in the center part. The cytoplasm is having a scattered arrangement of thin filaments and thick filaments. Do you have a comparison of number of thick filaments you see there in the smooth muscle compared to the skeletal muscle? Yes, a significant less number of thick filaments in the smooth muscle. And one more important thing that you can notice here, there is no sarcomere pattern of arrangement in smooth muscle. And you can see the thin filaments as it's scattered in the cytoplasm, they are interconnected by a specialized structure called dense bodies. It is nothing but a structural analog of Z line in the skeletal muscles. What will happen to these dense bars or dense bodies during the contraction of smooth muscle? These dense bodies come together. There will be a significant overlapping of thin filaments over the thick filament. What is the other difference that you see here in smooth muscle compared to the skeletal muscle? Are you getting a well-defined sarcotubular system in smooth muscle? Yes, you are not having it. What else is there as an analog? You can see that the cell membrane of the smooth muscle is having lot of invaginations. They are otherwise called caveolae. The caveolae are nothing but a structural analog of sarcotubular system in the skeletal muscle. Now we can take the excitability pattern of smooth muscle compared to the skeletal muscle. I told you both are excitable tissues. They are privileged with a resting membrane potential. But when we come to smooth muscle, you can see that there is no fixed resting membrane potential. The potential always fluctuates between minus 50 millivolt to minus 35 millivolt, like a slow wave. You can see there in the animation in the given frame, the membrane potential is always having a wavy pattern or undulation pattern. And on the summit of this wave, when it crosses beyond minus 35 millivolt, you can see there are spikes coming on it. These spikes are mainly caused by the influx of calcium ions. The number of spikes that comes on the summit of this slow wave determines the force of contraction. That means more number of spikes coming on the summit of this wave causes more stronger contraction in the smooth muscle. In the uterus, you can see a different pattern of membrane potentials, having a plateau phase and a spike, not like a slow wave. What is the difference in uterus? The contraction of uterus should be more sustained, more strong enough, and it should be more long lasting. That's the reason why it's having a plateau phase and on the top of that you are getting a spike. Of course, the spike and the plateau are mainly due to the influx of calcium ions. So there are two types of action potentials in the smooth muscles, as we just described, one having a slow wave with a spikes on the top. The other one is having a spike with a plateau phase.